Greetings and welcome to the introduction to astronomy. In this week's Astronomy of Other Cultures, we will be looking at or continuing looking at Muslim astronomy and talk about the astronomer al-Farghani and look at his contributions to astronomy. So let's go ahead and get started. And what we know about al-Farghani is that he lived from about 800 to about 870 and worked on astronomy in the city of Baghdad. Now here we can see a statue to his honor for the work that he did. And one of his major works was what is called the Elements of Astronomy on the Celestial Motions, which was a summary of the Almagest with some corrections for more recent findings. If you remember, the Almagest was published in the 2nd century. So here we are in the 9th century, nearly 700 years later. And we're then looking at what we have learned since then. So definitely updates could be made to this. Now we can look and see what he did, and some of his translations survive. So here's a page from one of his works translated into Latin. So the work of the Muslim astronomers was translated back into Latin and during the Renaissance and was used in various different areas. And some of the things that he worked on were things like looking at the size of the Earth and the tilt of the Earth. Now we may look, the ancient Greeks had made some estimates of the size as well. But we're getting more modern, we're getting better instruments, and we're talking many millennia later that we are now able to get even better estimates of the size and learn about the tilt of the Earth. How tilted is the Earth? So interesting, it is al-Farghani's estimate, which was used by Columbus in his travels. So Columbus knew the Earth was spherical. In fact, that's been well known since ancient times, that the Earth was not flat, but was indeed a sphere, even back to the ancient Greeks. But his estimate used by Columbus was a little bit smaller than the actual size of the Earth, which is one of the reasons Columbus thought he would be able to make it to the east, traveling from Europe. So in not knowing that how big the Earth actually was, because this estimate was still off, was one of the problems that eventually led to Columbus landing instead in the Americas, which were of course not even known, but in between the European area and the Far East. So we can continue that and look at what else he did, which was working on an astrolabe. And in fact, he gave us the earliest document on the construction of the and use of the astrolabe, which is a device. It's kind of, if you want to think of it as an analog computer to be able to figure out positionings. We're used to digital computers now, but analog computers where you could adjust this to a day and time, and then it would set and tell you the various positions of stars, planets, and would allow you to be able to learn things like that. Now al-Farghani gave us the document on the construction and use of this, and really gave us a theoretical basis for the construction as to how that would actually work, how to put together one of these so that you could use it as a computer to be able to determine positionings at various times as to where the various planets would be. So let's go ahead and finish up now with our summary. And what we've looked at today is al-Farghani, who lived from about 800 to 870, did work on summarizing and improving the work of Ptolemy in the Almagest, and gave us some of the oldest existing documents on the construction and use of the astrolabe. So that concludes this discussion on al-Farghani and his contributions to astronomy. We'll be back again next week to talk about another astronomer of the Muslim world. So until then, have a great day, everyone, and I will see you in class.